Okay, so I actually solved this last night and recorded the whole process, which is an hour. And then afterwards, I found out something wasn't working with the program, so I didn't actually get any sound recorded in. So that was a bit of a bummer. So this morning, I recorded it again to do a voiceover over the silent video. And then for some reason, it couldn't finish recording, so it was stuck on stop recording, so the whole recording was lost again. So I'm gonna try a second and the final time to do the voiceover on this. I guess it's telling me that it's just not the right time or something. All right, so I'm gonna explain the algorithm, try to remember what I was thinking, and we're gonna do the time and space complexity. And in the next video, I will look at other solutions and see if there are any ways to improve my solution. Okay. So we have a cooldown period, which is n, and that means if we have two of the same letter, which means the same task, we need to have at least 2 units of time in between. So if we have AAA, that means we have to have A something something A. So between each two of the same letters, it has to be at least the same amount of cooldown period in between. So what would be the minimum amount of units of time for example, 3 A's? We will need A something something A something something and another A. So that would be, we have 3 A's, we need 2 times 1 plus the cooldown period, which is 2. So 2 times 3 plus the last A plus 1. So that's the least amount of units we need for 3 A's with the cooldown period of 2. Okay, now we're looking at example 3. So we have 6 A's, which means we need to use at least 5 times 3. So 5 of those A's need cooldown period 2 units after them. So 3 units in total, 5 of them need 3 units each, plus the last one. Okay, it's really not the best way to explain when I'm speaking over yesterday's video. Okay, so special case. What if we have 3 A's and 3 B's? So we have A plus 2, A plus 2, and the last A. But we need to do the same thing with B. So how do we handle when there are more than one that needs to have this cooldown between them? Alright, so let's see. 3 A's, we need 2 times 3 plus 1, 7 units at least. And for the 3 B's, we also need 7 units of time at least. And they need to be together in the same output. So in this case, we need 8 units, and that would work because we can use the B and other task and idle to fill out those cooldown periods. So let's think, what if we had 3 A's, 3 B's, and 3 C's? We still need 8 units for A. No, we still need 7 units for A, 7 units for B, and now we also need 7 units for C. And what do we do then? Well, we would need 1 extra unit in the end in comparison to just the A's and B's, because now we're doing ABC, ABC, ABC. Alright, we're looking at example 3 again. So we have 6 A's, and then we can fill in the cooldown in between with other tasks. So we need to care about the task, the letter that has the highest frequency. Why? Because all the task and letters, they all need minimum n cooldown period. So we only need to consider the one that has the highest frequency because they need to be separated with all these cooldown units in between. And they will take the most space because we can fill in all the other ones between these. And since we're looking at the one with the highest frequency, we will not need to consider if there would be another element that couldn't fill in but needs extra space outside, because that element will be the highest frequency in that case. Okay, so our approach right now is to first find the element with the highest frequency. We need to know what that frequency is, and we need to also consider the special cases when there are more than one task that have this highest frequency. Okay, so I was still looking at example 3, trying to explain what I was thinking. But soon we will start coding this approach. Alright, so what do we need to do first? We need to count the frequencies of each letter. Look at the input, they're all uppercase English letters. So we just need a size 26 int array to store all the frequencies of these letters. So for each character in the input tasks, we just need to count the frequency of it. So we're doing for each loop. And the quick way to get the index is to just do the character minus the start of the capital. If it's all lowercase, we just do minus small a. Now it's all uppercase, so we do minus capital A. So with that loop, we have all the frequencies of all the letters in this freq array. And what do we need to know now? We need to know what the highest frequency is. How can we do that? We already have all the frequencies in the array, so we just need to find the maximum. So let's define an int called highest, which is just the maximum of this frequency array. And what will be the next step? The special case where we have more than one task, more than one letter that have this highest frequency. Let's count how many there are. So int count. Now we need to loop this frequency int array again. And each time we find a frequency that's the same as the highest, we just increase count. Then we will know how many letters have the highest frequency. Okay, now we got those two, highest and count. Now we just need to calculate the minimum number of units of time. Okay, simple case, what if we only have one that has the highest frequency? Then we so think of example 3. We had 6 A's. We're gonna do 5 times 1 plus n. And so we're doing, so n is cooldown period, and plus 1, that's how we were calculating, and highest minus 1. And then we need to also add the last one. And what about when there are more than one that have the highest frequency? If you look at example 2 or 1, we see that when we had 2 of them, we needed to add 1 extra in the end, and if we had 3 of them, we needed to add 2 in the end. So we're adding count minus 1, so it becomes just plus count. Let's run that. Okay, wrong answer for case 2, correct for case 1 and 3. Okay, case 2. Let's see why we got output 4. So we had 3 A's, so highest would be 3, n is 0, so we have n plus 1, 1 times 3 minus 1, so 1 times 2 plus count is 2, so we just return 4. And that is obviously unreasonable because the input array has 6 elements in itself, so it cannot ever be less than that. So my fix was to add in the first line, if cooldown period is 0, we just return the length. 61 of 71 paths, that's not bad, but we still need to handle more. It's not correct. What if we had 3 A's, 3 B's, 3 C's, and then D, D, E? So that's 12 elements. So it's gotta be at least 12. But what is the output we're getting? So N is 2, highest will be 3. So 3 times 2 plus count is also 3. We're getting 9. But we know that it's gotta be at least the length of the input. So how about we do the maximum of the input length or the calculation we are doing? Okay, so let's put that in. Let's do math max. Tasks length and that calculation. Let's submit again. Okay, a little more test cases passed. Now we have 6 A's and then B, C, D, E, F, G, also 12 elements in the input, and we're outputting 11. And this is for the count is 1 case. So we should also do the same thing for count 1. Well, there are no, yeah. Also math max, task length. And there we go, there we have first accepted solution. Exciting. Now let's see if we can optimize. Since now we are already using mathematics task length, we actually no longer need the first line when n is equal to 0, because that is now actually that's already accounted for. Yes. Oh, that is really good runtime and memory usage. So pretty happy about that. Okay, that's good. And then I was thinking, could I have done, instead of the 2 for each loops, could I have used link expressions to make it more elegant? Yeah, this whole part, if we can just write a link expression instead. But I need to brush up on my link, so we can do that in the next video. And now let's see anything else that I could refactor, or probably not at this point. let's do the time and space complexity analysis, and I will film another video and look at other solutions and see if I can make my code better, or if there are other approaches that would also be very interesting to see. Alright, let's talk complexities. Even though I'm still doing other stuff there. Okay, so let's look at the algorithm. First, we are doing one loop in the input. Yes, there. So what's the time complexity there? It will be linear with respect to the size of the input array, because we're just looping it once. Okay. What about this loop? So this is actually the int array frequency, which is only size 26, and it will not change no matter the size of the input. So that would actually be a constant time. And the rest of it is all constant because we're just doing some calculations and declarations. So in total, this whole algorithm would be constant. Would be linear in time, O of n, when n refers to the size of the input, not this n, which is the cooldown period. Okay, now let's think about space complexity. So we are using an input, we're using an int array frequency which has constant space because it's set to be 26, and now we're also using some integers, and that's really it. So space would also be constant. Alright, so we have an O of n, which is a linear time complexity algorithm with constant space complexity, which is really good. Yes. Okay, I'll stop here because now I'm gonna start trying to write the link expression. So I will do that in the next video. Okay, stop recording. Yes.